So I wanted to walk through setting up this Excel problem that we did in class earlier today. And so again, we're looking at a reactor that, let's just go up to our notes up here. So our reactor, non-steady state reactor, and we're changing, so we've got the concentration turns to 0, but our concentration inside the reactor is at 32 milligrams per liter. And we want to find out the concentration out. How long would it take for the tank to reach 10% of the initial concentration of 32 milligrams per liter? And note we're putting in clean water that does not have anything inside there. So I asked you guys to essentially solve and graph this equation I got highlighted in yellow and plot and find out what this looks like. So let's go on to Excel. And so what I've done is I've used a window snippet and copied this equation, and I pasted it right here. I've got my variables that are defined. So here's our initial concentration, 32, no units with them. I'm just putting units in a separate column. We've got Q, 50, volume, 500, and K given. So I believe that's going to be a negative on there, but let's so we got days, so let's just go 0, 0.5, 1, 1.5, and let's go ahead and copy this trend down. So we can just click right here, and let's just get this up to about 10 days. Oops, don't want to, well, that works too. So let's just drag this down, so it's just taking the same trend. Alright, so concentration. So going back to our key equation that's up here, we need to put this into essentially Excel verbiage. So this would be equal to C naught. So C naught, and let's give that a F4 so we can copy and paste these cells down quite equally, times EXP parentheses. And it looks like negative, and then parentheses again, Q. So Q would be this cell, F4, divided by volume, this cell, F4. Alright, so we've got that. Now let's put another parentheses here. We've got a whole lot of things going on. And then plus K. Make that an F4. Alright, so every time I hit these parentheses, we can see trends that are happening times T. So T would be this cell right here. And hit parentheses there. And we get that concentration is equal to 32. So again, at times 0, it should be that initial concentration. And let's just make sure all our cells are referenced correctly. One way that I like to track these, if you go to review formulas, so we can trace precedence, trace dependence. So this equation's using these cells that are highlighted on here, and we can find out what cells are actually dependent on that as well. So it's a good way of kind of tracking your equation. If you get up here, you can actually highlight. So you got the orange, and that means that that's that cell for orange that's there, and so you can color. You can see what all the cells that are referenced in that particular equation, what they are. So let's hit enter there. Let's remove those, remove the arrows that we had showed. Alright, so let's copy this down, Control C, and let's just drag this down, and Control V, paste it down, and we've got some sort of trend that's happening here. Now remember in class the answer is about 7.3 days, and so where it gets down to about 3.2. So we have that, and we could break up this time to get much better resolution with this if we wanted to, perhaps in future problems. So this looks good. Our concentrations look fine. Now we got to plot it. And so let's go to, how do we insert? Let's insert a chart. What I typically like to do is to highlight the cells that I want to plot. And let's get an XY scatter plot. And there we go. So we've got this plotted on there. And we can change some of the attributes that are on here. We'll go ahead and get rid of this title. And alright, so if we want to add points, connectors between there, Actually, first let's go to add an axis. How do we add an axis? So chart type, rows, columns, design, major grid lines. Alright, so I typically like to get these nice and pretty, so I'll bold this axis here, I'll bold this axis here, and let's go down, and let's go to move data, bring back, format chart area. That's what we want to do. So here we get some chart options. That's what I'm looking for. So horizontal value axis. Alright, so we've got the axis that's highlighted on here, but we can actually, okay, major grid lines. So let me pause here for a second and find out how to add that. Alright, I'm getting confused on this new version of Excel. I haven't plotted a whole lot of things on here, but it looks like we can add chart element, add axis title, so we can go primary horizontal, and let's make this concentration milligrams per liter. Alright, then let's go to add axis title, and let's go to our vertical one. And so this would be actually concentration milligrams per liter. We got to change that other one back to, so let's just highlight here, time, day, and hit delete on that. There we go. So now we've got a nice pretty graph. Now I'd like to see a line here, so let's just see if we can right click on here carefully with a pen. Series options, shadow, so let's got fill, we got series options, plot series and primary axis, so we can change that. So let's put a line on here, so let's put a solid line. Oops, we don't want that, not just on one, but we want the whole series. So let's just click on the series, solid line between there, and voila, there we have it. If we wanted to get the trend line of this data set, so typically you can just right click on here and add a trend line, and we can put linear. It's definitely not linear. Now you can see the differences there. It looks like it's an exponential. Well, exponential shows it pretty well. And so trend line, and we can even put a trend line name of the series, and let's go ahead and display the equation and the r squared that's there. And so there's our, if you look at that equation itself, it actually calculates to be exactly what we are trying to plot, r squared equal to 1. And so if we wanted to find out exactly when that concentration was 10%, we could put in the values and solve for perhaps t. On this one, this would be, we can solve for x on this equation would be t for time, and we can solve exactly when that point is. So there's a nice graph. Sometimes I like to bold these axes here. Concentration, to make that nice and bold, and there you go. That's exactly what I'm looking for. And so hopefully that helps out. There'll be lots of graphing in this class. So certainly brush up on your graphing skills with Excel.